odorless, it's colorless, and it's lighter than air. It's also the main ingredient in the formation of stars, and it contains a lot of energy. How much energy? Try enough to power the sun. It's energy we want to use to power all sorts of things, from cars and houses to laptops and cell phones. It's hydrogen, and it's the most abundant element on Earth. Well, it turns out we are. We already use hydrogen to power space shuttles. And several car companies have built hydrogen-fueled cars. Some are already on the road. There are even hydrogen-powered buses, boats, and airplanes. But unlike other fuel sources, hydrogen can't be harvested easily because hydrogen gas is very rare in our atmosphere. Due to its light weight, most of it escapes from Earth's gravity. So instead, we have to make it, and that can use a lot of energy.
One way to make it is by splitting water into hydrogen and oxygen. And the setup here is designed specifically to split water into hydrogen and oxygen. It's the basic process of what's called electrolysis. The name of the game scientifically is how do you do that process with the minimum input of energy so that no energy is wasted, while still having the reaction be fast enough so that you get enough hydrogen to use for a day or for whatever application you want. The key to that question is how to make the reaction fast without applying more energy. And the way to do that is to use a catalyst. What a catalyst does is it accelerates the reaction without needing you to apply more additional energy that might be wasted.
Even with the help of a catalyst, electrolysis, or the splitting of water into hydrogen and oxygen, still requires electricity to drive the reaction. And unless that electricity is green in the first place, making hydrogen gas isn't a completely clean process.
The key to that means taking sunlight and converting it into electrical energy and then using that electrical energy to store in the form of a chemical fuel like hydrogen and oxygen, and then using those chemical fuels in a fuel cell to convert them back into electrical energy to use when the sun doesn't shine.
Fuel cells are sort of like batteries, except that as long as we keep adding hydrogen, the cells will never run down or need to be recharged.
What we're trying to do ultimately is figure out ways to have energy come from the house, to have your house be a power plant and the source of all the fuel that you need to run your life.
A single fuel cell consists of a positive electrode, a negative electrode, a membrane, a catalyst, and a wire circuit outside the cell. It works like this. Hydrogen gas enters the fuel cell and reacts with a catalyst at the anode. This helps separate the electrons from the protons. The positively charged hydrogen ions, protons, can pass through the membrane. As the electrons build up, they start to push against each other, like repelling magnets. Eventually, they end up pushing each other through the path of least resistance, across the wire circuit. This flow of electrons is electricity. When they reach the other side of the fuel cell, the electrons reconnect with the positively charged protons and combine with oxygen to form water.
So in here is basically we have fuel cell where you have hydrogen molecules coming in from one side and oxygen molecules coming in from air. Within the heart of the fuel cell, we have basically two catalyst layers, and then we have ion conducting membrane in between. So on one side, we're splitting hydrogen molecules. On the other side, we split oxygen molecules, and they combine to form water. At the same time, we generate electricity.
So we're getting energy out, and then the only waste or leftover is just water.
Right. Perfect.
So by turning our houses into hydrogen gas stations, we would have fuel for everything, even our cars, without harming the environment. It's such a simple idea, too. Store excess energy during the day, and then use a fuel cell to convert that energy back to electricity at night. So if I'm converting water into hydrogen to make fuel for my house and my whole life, how much water am I going to need for that?
Well, it turns out that chemical bonds are really strong, and so you store a lot of energy when you make hydrogen gas, and so you don't need much water. It turns out with just a few liters of water, and you convert that to hydrogen and oxygen, that's plenty enough for an entire day for a typical house.
Someday, All of our houses, offices, and schools might also be mini hydrogen power plants that we can use to fuel our lives. Because sometimes it only takes a little to do a lot.